This video covers the review exercises for section 2.2. Graphing tangents, cotangents, secants, cosecants. When graphing tangent functions, we have to remember that their period is pi. And if you change the period on the basic tangent, like tangent 2x, then the new period becomes pi divided by 2. So the new period being pi over 2, one full cycle happens in pi over 2 seconds. So we have to have a period of pi over 2, which now means this graph is going to go from negative pi over 4 to pi over 4, giving us one full period of pi over 2. The basic tangent function looks like that. And halfway between those, this is going to get up to 4. Halfway between those, it's going to get down to negative 4. So that's essentially what the graph looks like, and we're going to put this on the graph paper down here. So we're going to go out negative pi over 4, and pi over 4 are going to draw our vertical asymptotes. Halfway between those marks, it's going to get up to 4 and down to negative 4. I want you to mark off the axes. This we said was pi over 4, which means this is pi over 8. This is negative pi over 4. Sorry, this one's negative pi over 4. And this one's negative pi over 8. All right, we need 2 full periods for this graph. So we're going to extend the graph to the right and to the left of this. So my tick marks are going by pi over 8s. So here's one of my pi over 8s, 2 of them, and 3 of them, and 4 of them. 4 pi over 8s is pi over 2. 1 pi over 8, 2 pi over 8, and 3 pi over 8. So now we have to imagine that we're taking this full cycle and shifting it over to the right to gain another cycle. So this from pi over 4 to pi over 2 is just half of the cycle, so it's this piece that gets transferred over there. So remember the negative pi over 8 was at negative 4, so 3 pi over 8 is at negative 4. Now we're going to take this full graph again and shift it to the left. Negative pi over 8, negative 2 pi over 8, negative 3 pi over 8, and negative 4 pi over 8. And it's going to be this portion of the graph that gets moved over to it. So remember, halfway between it goes up to 4. And there's the graph of 2 full periods of 4 tangent 2x. Okay, so remember, I want you to label the axes with these tick marks of the key points. And I want to make sure for the tangents that you know where these points are, the 4. For number 2, it's a negative tangent. Negative tangents get flipped over. They start positive and go negative. Here the period's been changed. The new period is pi divided by pi over 4, or which becomes now 4. So a full period of this is 4, which means it's going to go from negative 2 to 2. So I'm going to start ticking this off. Negative 2, negative 4, 2, and 4. Here are my vertical asymptotes. And halfway between those, which is -1 and 1, this is where it gets up to the 2 or down to the -2. So we have that graph, and then the other part of that. So there's one cycle of the tangent function, and then we're going to draw the other periods. So in this region here, we're graphing this half of it. So halfway between it is at 2. And then this region here, we've got this portion of the graph. And remember, I want you to label all of these key points: -1, 2, -3, -4, and 1, 2, 3, 4. Okay, so there's the 2 full periods of that tangent function. Now 3 and 4, these are the shifting of the tangent functions. These are what we call phase shifts. And so I'm thinking this x plus pi means that I'm shifting my graph pi units to the left. So if I shift this graph pi units to the left, a tangent graph that already is a period of pi, and I shift everything over pi units, I get the same exact graph. So we're saying that tangent of x plus pi is the same thing as tangent x. So we're going to just go ahead and graph the regular tangent. Tangent having a period of pi goes from -pi/2 to pi/2. Halfway between these is pi/4. Goes through 0, 0. At pi/4, it's at 1. At -pi/4, it's at -1. Now we draw the other half of the period on this side. This is 3pi/4 and pi. So we draw the negative portion on this one. 3pi/4 is at -1. And over here, we've got the positive portion of it at -3pi/4. It's at 1. Number 4, this is the shift of the graph of negative tangent x pi/4 to the right. So I'm going to think of this graph first as the negative tangent x, which is the graph of number 3, but flipped over. This being -pi/2, and this point being -pi/4. So now if I shift that graph pi/4 to the right, every feature of it shifts pi/4 to the right. So think about where this point is. The -pi/4 is at 1. That means when I shift it to the right pi/4, it's going to be at 0, 1. The point, or the asymptote -pi/2, when I shift it to the right pi/4, it's now at -pi/4. The right side of this was at pi/2. You shift that to the right pi/4, puts you at 3pi/4. the 0.00 moves to pi over 4, 0, and we have the left side of the period. This was at pi over 4, -1. Now it's at pi over 2, -1. And so we can see how this graph works now. We're going to be ticking these off in the multiples of pi over 4s. Negative pi over 4. 1 pi over 4, there's 0. There's pi over 4. 2 pi over 4. 3 pi over 4. 4 pi over 4, which is pi, and 5 pi over 4. The graph starts at negative pi over 4 and ends at 3 pi over 4. Here's your 0 mark. This is going to be at 1 and -1. Now we transfer that picture to get the other cycles. So over here is going to be the positive 1. At pi, we're at 1. At pi over 4, we're at 0. And over here is the negative side. This is 1 pi over 4, 2 pi over 4, and 3 pi over 4. And we have the negative side of the graph. And there's our 2 full periods of negative tangent x minus pi over 4. Shifting to cotangents, we remember that the cotangent base graph, it looks a lot like a tangent. However, we graph this one from 0 to pi over 2. Sorry, it's a period of pi, so it's from 0 to pi. In the first quadrant, it's positive. In the second quadrant, it's negative. And so what we're graphing is a period change. Period is pi divided by 3. So 1 full period of this is going to be pi over 3. 2 full periods of it is going to be 2 times pi over 3, or 2 pi over 3. We know halfway between it, it's going to get up to 2. There's halfway between the cycle up to 2, and the other halfway point down to -2. 0 to pi over 3 is a full period of this. Break this one up into its fourths. 2 and -2. Okay, last thing to do is just mark off the axes where these points are. So the way I do this is I look at pi over 3 first, and then I know half of pi over 3 is pi over 6, and then half of that's pi over 12. That means that every one of these tick marks is pi over 12 long. So this is 1 pi over 12, 2 pi over 12, 3 pi over 12 is pi over 4. 4 pi over 12 is pi over 3. This is 5 pi over 12. 6 pi over 12 is pi over 2. 7 pi over 12. And 8 pi over 12 is 2 pi over 3. So that's the graph of 2 cotangent 3x. to graph -2 cotangent pi over 2x, first we want to look at the period. Pi divided by pi over 2 is a period of 2. So we're going to go 1 full period of 2. 2 full periods is 4. There's the 2 full periods. We will go to cutting this period into half and then a quarter. And remembering that the negative takes this graph and flips it over. So we're going to start in the negative region and then go positive. So halfway between it is where it's 0. Half of that one is where it gets down to the -2 and then up to the +2. We go over to the next cycle, half and half again. This is where it's -2, and this is where it's +2. Now let's put in the numbers. So we took the 2 and cut it in half and made that 1. This one's going to be 1/2. 3 halves, 4 halves, 5 halves, 6 halves, 7 halves, and 8 halves. Last one for the cotangent. Now we've got a plus pi over 2. So we're taking the graph of cotangent that goes from 0 to pi, and this point being my pi over 2. And we're going to shift everything to the left pi over 2. Shift everything to the left pi over 2. Okay, so then shifting everything to the left pi over 2. This vertical asymptote is now going to be at -pi over 2. The pi over 2, 0 is now going to be at 0, 0. We're looking at this now. And the pi gets shifted left pi over 2 to pi over 2. So essentially looks like the tangent graph reflected about the x-axis. And so then we'll remember these critical points are going to get us up to 2 and down to -2. All right, so it looks like our tick marks then need to go by pi over 4s. So we got one pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, and 6 pi over 4. So pi over 2 is our vertical asymptote. And then we'll put our first cycle of cotangent in there. So we know that this side's going to get us up to 2, and this side's going to get us down to -2. And now we'll put one more period over to the right of that. This one's going to be our 0. This is going to be our 2. And this is going to be our -2. And this is going to be our vertical asymptote. Let's go ahead and put our markings on our x-axis there. Pi over 4, 2 pi over 4. Then 6 pi over 4 is 3 pi over 2. All right, so shifting to secants and cosecants, we're going to be going back to essentially sines and cosines, remembering their periods are 2 pi. So when graphing a secant and a cosecant, we first graph their reciprocal function. We first think of this as 3 cosine 2 pi x. And we graph that on there. And we use those values to find the asymptotes for secant. So 3 cosine 2 pi x has a period of 2 pi divided by 2 pi, which is 1. So we know we're going to be going between -1 and 1 to get our 2 full periods. The highest this graph is going to get is going to be 3, and lowest is -3. So half of those are breaking this up into its quarters now. 1/2, 1/4, and 3/4. -1/2, -1/4, and -3/4. And so the cosine starts at its max and then goes average, min, average, max. So we draw these dashed lines to put that graph on there. So remember, where this cosine is 0, when we take the reciprocal, is where it's undefined, and we get these vertical asymptotes. So where the cosine is 0 is where our vertical asymptotes are, because when you take the reciprocal of a 0, you get undefined. And then where the cosine is 1, when you take the reciprocal of 1, it stays as 1. So that's where the graphs start. And then any of these guys in between 0 and 1, when you take the reciprocals, they become bigger than 1, and they shoot off to positive infinity. So we just make our graph come close to the asymptotes. And that's what the graph of 3 secant 2 pi x looks like. Number 9, if we're going to do -2 cosecant pi x, we first start by graphing -2 sine pi x dashed. And the period of this is 2 pi over pi, which is 2. And so we go through and graph 2 full cycles of this. Of the -2 sine pi x. -2 is going to start off as its average, and then it's going to go down to a -2, back to average, back to 2, or to 2, and then back to average. Graphing all of those is not really all that necessary. What's necessary is showing where this graph is 0 to get our asymptotes. And then knowing that where it's 1 is where these graphs are starting from. So sometimes then I would rather than dash the whole thing, just put my points that are necessary on there. This one got a little bit too large on me there, or too far away. Should be at -2. And so I know this is where my asymptote is. And then this is where my graph starts. Graphing secant, cosecant with a phase shift. Again, we start off this one as graphing 3 cosine x plus pi. So we're going to graph 3 cosine x plus pi by shifting everything to the left pi units. So typically our cosine looks like that, and everything's going to be shifted left pi units. So the original point was 0, 1. That's going to be shifted over to pi 1, or in this case, 3. Shift everything to the left pi. This point was pi -3. Now it's 0, -3. This point was 2 pi 3. Now it's pi 3. So we've got our zeros in between those. And you see really what all we're doing is graphing a -3 cosine x. If you shift a cosine wave pi units to the left, you end up with the -3 cosine x. And so this goes back through 0. And then this one goes back to -3. All right, so we've got the nice characteristics, key points. This is where it's 0. So we have an asymptote there. And this is where it's 0. So we have an asymptote there. All right, last thing to do is put our tick marks in there. We had the period of pi. Sorry, period of 2 pi. And so this one's 2 pi. This one's pi. Pi over 2, 3 pi over 2. -2 pi, negative pi, negative pi over 2, -3 pi over 2. And the last one for cosecant x minus pi. We're going to first start off with the graph of 4 sine of x minus pi. Remembering that the sine wave typically looked like this. Started at 0, 0. At pi, it was at 0. At 2 pi, it was at 0. And we're moving everything to the right, pi units. So the 0, 0 is now going to be pi 0. The pi over 2, 1 is now going to be 3 pi over 2. In this case, it's going to be 4, though. So thinking about how this graph would look shifted pi units to the right, it's going to be the sine wave flipped, -4 sine x. So this graph is going to start average, go max, go back to average, and it's going to be -4 and 0. Doing the same thing on the other side. Now we have all of our key points on there. Where it's 0 is where we get vertical asymptotes. And where it's 1 is where the graph starts. And that's the graph of 4 cosecant x minus pi for 2 full periods. And this concludes the video for the review exercises for section 2.2.